Ryan from Codable here, and today let's talk about strings and why they're different from primitive data types. If you look at this example above me, you're going to see a blueprint and an arrow going over to a house. And essentially that's a very elementary way in which we create homes, at least here in the US. You build a blueprint and the architect, creates the house according to all the specifications, all the materials, lines out everything that's supposed to be done in the house, and then those plans get handed off to the people who are then going to build it. And they use those plans to construct a home. You've probably done something similar playing with a toy like Legos. You get a Lego kit and it comes with a booklet that explains how to build some specific things with that set of Legos, right? We're going to understand strings through this exact analogy by understanding that in Java, blueprints and classes are kind of the same thing. We can write classes and basically define everything within them. So we create this blueprint, and not only does it physically have all of the attributes that we want it to have, but it also has a lot of action code within it as well, meaning that we can define what that class can do and how other classes can work with it. And just like how you build a neighborhood, you're really just organizing a series of blueprints. Java works much in the same way. Now, once we've used that class and we create an example of it, like a thing you could actually hold in your hand. So think you take the booklet from your Lego kit and now you actually build the thing in the book and you're holding it. When we do that in Java and we create that thing, we call that thing an object that we're holding in our hand. And when you think about it like that, it's like, that really kind of makes sense. The class is the blueprint, and once we create something based off of it, we call it an object, because it could be literally anything. So today when we jump in the IDE, you're going to notice a few things. You're going to, number one, notice that string, when we call it as a data type, is going to be capitalized. This is a dead giveaway that string is an object within Java. When you see a data type that has its first letter capitalized, that's setting it apart from a primitive data type, which is all lowercase, and lets you know that that specific object has a lot more functionality under the hood that you want to learn and get to know, because you can do some powerful operations with it. So now that you understand that strings come from the string class, which is like their blueprint, and we use that to create string objects and use them, take that in your head and let's walk into the IDE and figure out how these work in real code. Now, if you look at the IDE, you're going to see that I have one line of code here where I've created a variable. I've called it name. It's of the string data type, which you'll notice, like I said, is capitalized, meaning that it is an object that we're creating. And then I've instantiated that with the equal sign to mean that I want to store Ryan, from Codable, ! inside of that variable, right? So here you see I have Ryan from Codable. We could print that out. We could, display it on screen, whatever we want to do with it. But I want to take a look at specifically why objects are so much stronger and so much more powerful than our primitive data types. So here I have a print statement, and like I said, I could just print out name. But because string comes from a class that has a bunch of different functionality already designed into it in Java, I can actually transform some of this data, and I could use something like to uppercase, right? And then when I run that program, you're going to see that it capitalizes all the letters. It's Ryan, from Codable, ! You could do the same thing with to lowercase. We run it. We see the same exact example, but now all the letters are lowercase, right? So because we declared this from a class that had a bunch of functionality written within it already, we're able to pull some of that functionality out and use what we call dot notation. That means I use this little dot here, this period basically, to call a method that exists within the object. So let's stop there before we get too confused, because we will cover this in detail many times in the future of this course. Let's just recap what we've learned and talk about how strings are different from primitive data types. If you can walk away with that information, then you have been successful in watching this course thus far. Remember, we learned that strings are not like primitives because their data type has a capital letter at the beginning, whereas primitive data types have a lowercase letter. So they're already differentiated in Java. We learned that Objects, like the string object we created here called name, they come from classes, which are kind of like blueprints. And those are powerful because we can use that blueprint, that plan essentially, to build as many of that same object as we want to, right? So primitives and strings are not the same thing. You learn them around the same time because they're all very basic forms of data, like the ability to write numbers or letters or craft out words, right? That's all a very beginner Java concept. But as we progress through this course and you start to build programs with classes and objects, you're going to fundamentally re-see the way that strings actually work, and we're going to change your paradigm on that, okay? So, thanks for sticking here. You could have been anywhere today and you were here. I appreciate that, and I'll catch you in the next video.